symbols to letters. So aluminum is what? Al, and it's a compound, so we're going to do what? We're going to look up the and crisscross, right? So Al has a 3, bromine has a, and we're going to bring the 3 down. Plus, lithium oxide is a what? Li, and O is a compound, so we're going to look up the oxidation number. So a 1 and a 2, bring our 1 down, bring our 2 down. Again, lithium bromide is a compound, so I'm going to look up the oxidation number. Now, the reason that I often leave the oxidation numbers up here is sometimes when I don't, students will look these up again. Is there any need to look them up again? No, you got them right here. So lithium was a 1, bromine was a what? So what's going to happen to the 2 1s? They're going to do what to each other? Yeah, but they're also going to cancel each other out. You don't even have to bring them down. And then you have aluminum oxide. Aluminum plus oxygen. Aluminum oxide. Aluminum has a 3 and oxide has a 2. So 3 and a 2. 2 comes down. 3 comes down. Okay? Now you can go back and either rewrite it or erase. Both ways. All right. So, who do you want to balance first? All right. Who do you want to balance first? Those? Sure. All right. How many lithiums are here? What you gonna put here? Okay. So there's 2 lithiums. How many BRs did you make? You made how many lithiums? How many lithiums are bromine? Sorry. 2 lithiums. So how many bromines did you make? How many bromines are here? Can I make 2? All right. So that's probably not a good place to start. So if you erase that and pick something different. Okay. How many lumens are here? How many are here? So what am I gonna put? Okay. How many BRs is that? How many do we need here? So how many lithiums do we make? How do I get 6? Okay. How many O's do we make? How many O's are here? All right. Did I miss anybody? Okay. Question. All right. So if we look at number 2. All right. So manganese 5 oxide. That's a compound again, right? So manganese has what oxidation number? Okay. Oxide has a, so 2 comes down, 5 comes down. Plus fluorine. What's fluorine this time? Is it a compound? No. It's an element. So what do we ask ourselves if it's an element? Is it one of the 7? Elements do not get subscripts unless they're one of the 7. All elements have no subscripts unless they're one of the 7 diatomics. Is it one of the 7? Then you put a 2 on it. Okay? So, becomes what? Manganese 5 fluoride. So manganese has a 5 again. Fluoride has a 1. 5 comes down, 1 comes down. Plus oxygen. Oxygen again is an element. Is it one of the 7 elements? But it gets a 2. Because again, elements don't get anything unless they're one of the 7. All right, is it balanced? No. All right, so if I balance it, what do you want to start with? Okay, 2 to 1, so you're going to put a what here? How many F's did you make? Okay, how do I make 10? 5. How many O's are here? What am I going to put here? How many O's did you make? How do I get 10? How many M's did you make? So I need to make 4 here. So what are we going to put here? Okay. How many F's did you make? How do I make 20 here? Question. All right. So the last one in the opening was number 3. All right, so if we look at number 3, how many carbons? How many H's? All right, so how many O's? Can I erase this? 5. All right, so how many O's did I make here? Plus, how many O's did I make there? Okay? It is. What does that go there? Oh, not right. Oh, it's going to rock one. Not have children. Oh. Wonder I'm not in jail. How many H's? You need a 5 there. Yeah. All right, so how many O's? All right, 4 times 2 is 8. I'm ahead of myself because I'm thinking what I'm going to tell y'all to do. So 5 times 1 is 5. So 8 plus 5 is how many? So we got 13 there. No. You can with a fraction, but we're not going to do that. All right? So I know I did this in 4th period. I can't remember if I did it in y'all's class. Anytime you get an odd number and you get a weird number, you can do this with any equation, but particularly with combustion reactions. Get rid of your coefficients that you have and put a 2 out front. That's going to help you now get an even number on all of your other coefficients, okay? Which is why I put that weird number I just did all the water. All right, how many C's do you have now? So what do I need to put here to get to 8 C's? All right, how many H's do I have? And that's why I put 10 here a second ago. 10 times 2 will give me 20. Now, when I add my O's, I have how many here? Okay, you use the calculator. Plus, 10 times 1 is? Okay, so we get 26. Now, I understand completely. So how can we get 26? 36. Okay, question? No? You're okay with that? If you wanted to, we can. What type is the top one? All compounds. Compound plus compound, we get a compound plus a compound. Okay, what was the second one? Huh? It was a compound plus an element, compound plus an element. And the last one. Yeah. Any questions? All right. You want to look at homework real quick before we do the quiz? Because it'll have some balance things to go with it. All right. I think I can pull that up. No, they're not. It's just balancing the work problem to be able to quiz. So just balancing. Oh, do you have a lab to give me? Okay, put it on my desk so I don't mark it late. It's electric. And then get what? I'm not going to say anything else. Yeah. Just don't have to sound it. It also means legal. Okay. It's always good to know when you have to classify that. Yeah. This is homework. This is the 4 problem. Oh. All right. So magnesium bromide is a compound. So magnesium bromide has a 2 and a 1. You get a 2 there. Plus chloride. Chlorine is an element. Is it one of the 7? Yes, it gets a 2. Plus magnesium chloride is a compound. So we're going to crisscross. And then bromine is an element by itself. It's one of the 7. It gets a 2. So if I take out those oxidation numbers I used, when I finish, what do I notice about the equation? It's already balanced, so I'm not going to write in anything. It is completely finished. Okay? Number 2, zinc is an element. Is it one of the 7? I'm putting nothing on it. It's just zinc. Plus hydrochloric acid. What's this symbol? One of the four y'all are supposed to know. Zinc chloride. Zinc has a 2, chlorine has a 1. I'm bringing my 2 down. Plus hydrogen. Hydrogen is one of the 7, so this time I put a 2 on. I get rid of my oxidation numbers that I've written up there, and I'm going to balance it. I need a 2 there to balance my H and my Cl. Questions about the second one? That's what? Writing word equations is not on today's quiz. It'll be on Wednesday's quiz. But you have to be able to do this to do today's lesson. If you can't do this, today is a nightmare. I'm just telling you ahead of time. If you want to write like 1 year, that's fine. I'm not going to take off for that. Okay? I don't write them, but if you want to write them, it's fine. All right, number 3, you have aluminum sulfate. You're going to have a 3 and a 2. The 3 is going to come down and 2 is going to come down. Plus potassium has a 1. Oxalate is C2O4. You're going to have a 1 come down and a 2 come down. Here's the little jacked up there. 2 with a 1. Nil. What do we get first? Aluminum oxalate first. So we're going to have a 2 here. C2O4 with a 3 here. And potassium sulfate here. All right, so to balance it, what do you want to balance first? What? Sulfate. So how many are here? How many are here? So we're going to put a, okay, how many potassiums did I make? How to make 6 potassium? How many oxalates did I make? How many oxalates are here? How many aluminum? How many aluminum? Voila. All right, the last one, manganese 7 chloride. Manganese chloride has a 7 and a 1. Plus nickel has a 3, and carbonate. Carbonate has a 2. Let me fix that. 2 for carbonate, 3 for nickel. And we're making what? Manganese 7 carbonate. Manganese has a 7. And what else do we got? Nickel 3 chloride. All right, what do we want to balance first? Okay, how many carbonates are here? How many here? What are we going to do? 7 and 3. How many nickels did I make? And I made 14. All right, how many chlorines did I make? 42. How did I make 42 here? 6 times 7 is, there you go, so I made 42. How many manganeses? How many manganeses? Voila. Mm-hmm. That was why there's a 2 there. So there's 2 chlorines. So I put a 2 here to make 2 chlorines. Even if it's what? You mean why this 2's there? That 2 came from the oxidation number, right? So I put a 2 here to balance the chlorines on this side. Because there's 2 on the other side. All right, and the last part of your homework was type. So we go to, nope, it's on Wednesday. I told you, today's only balancing. All right, so question number one. What type is number one? It comes up here. What's number one? Number two? A lot of these are going to be the same. Double. Number 3, 4, 5, 6, 7. I have another worksheet. I'm going to give you a type. This one, it should be what, 8? So 8, 9, 10, 11, 12, and 13. Yeah.
Oh, well, I guess that's true.
We need to get them for the phone. Somebody loan Shatoria their notes if you can get the types to react better. Do you have access to a computer? Huh? No. That's right, they're on YouTube.
Well, I can do it on my phone, though, but.
1, 2, 3 was double, double, and double. Alright, give me a present.
Wait. I'll do my best. I'll take a picture and then.
I'll be glad to show you again. But when those of you who did the backside, like several people before you know we did it, I never assigned the backside. I thought it's down. I mean, how many times y'all want me to say that? I'm not surprised, but like, how about a whole, I know you have projects.
Number 1, I don't think this is.
Oh, my God.
I only have this.
Oh, no.
Trim the edges off.
Right, that's what I like to
That's the Wednesday.
Let me tell you. Oh, these are warm up. Never mind. I wrote it. I was the last. You're fine.
We only went like 30
Now, you do not get a half hour back. Let me be clear about that half hour. Look at the clock. You can have 15 minutes. There are only 7 questions. We're not killing an hour balancing 70 questions. No. We are not listening to you. This year? Yes. I can usually use this tool when we find your call.
I think you're going to write a half day like that. I think I gave you one.
get better than it is tomorrow. Tomorrow we'll be listening to the band. On the rest of the week.
to work. Yep. Yeah. I was born. You know what now? The order. Plus what? Here. All? Oh, I see. Thank you there.
All right. If you will, find your notes. You are going to need your Exercise sheet today.
Make sure you don't have any golf.
All right. I know. All right. Before we can move on to predicting, you have to be able to tell me what type of reaction you have based on half a reaction. We call, if you want, call them predicting props. Props. Prediction. Props. Now, the next several days, this is all you're going to get of reaction. You're going to have to figure out everything on the right-hand side of the arrow. Okay? So, the first step you have to know is what type of reaction you have. We're going to start with single and double displacement today. We will build to combustion, synthesis, and decomposition tomorrow and Wednesday. So, when you look at that first reaction, what type is it? What can you tell me in looking at it? First of all, does it have a plus sign? Okay? There is no plus sign in that reaction. So that should tell you it's what type. It's decomposition. As soon as you see that there is no plus sign, that should tell you that that's a decomposition reaction. Is everybody with me on how I knew that? Okay. And the second one, you have a plus sign. So that leaves us the other four. Decomposition is out. Is it an element plus a compound? It's two elements. So, if it's an element plus an element, okay, that tells us it's not what two types. Okay, it's not double because it's not a what plus a what. It's not a compound plus a compound, it's double that. It's also not single because it's not a what? It's not an element plus a compound. The single and double are out. Now, That leaves us with synthesis or combustion. Now, what's combustion have to be? Carbon, a hydrocarbon plus oxygen. Do we have either of those? No. So that means this has to be what? Got to be synthesis. All right. What can you tell me about the third one? All right. So is it decomposition? No, because it's got a plus sign. Is it combustion? No, because it's not a hydrocarbon plus oxygen. So you've already eliminated decomposition and combustion are gone. You're down to either single displacement, double displacement, or synthesis. Why is it single? It's an element plus a compound. As soon as you can tell me it's an element plus a compound, it is single displacement. Now, the fourth one should slap you. What's number 4? It should slap you. It's 2 big compounds. It is double displacement. It is a compound plus a compound. And when we start predicting, they're the ones that have the least number of mistakes amongst students. They are generally balanced the best, and they are predicted the best. Even though they look the worst up there, they are the ones that by and large have the fewest mistakes. And number 5, which is the one I think is the easiest to identify, is usually the one with the most mistakes. And it is combustion. Now, any guesses as to why it has the most mistakes? It looks like a compound plus a what? So what do you think people tell me it is? Yeah. But then when you try to figure out the oxidation numbers, which I'm going to show you how to do in a minute, people have no earthly idea what the oxidation numbers are. They go, Ms. Wall, you think I like 10 for an oxidation number? What's the oxidation number? What am I supposed to use? As soon as you get in that quandary and you can't figure out the oxidation numbers, you should take a step back and be like, whoa, I'm doing something wrong here. Because you would not have given me something that I can't figure out the oxidation numbers for. Okay? It's not single displacement when you can't figure out the oxidation numbers. Just a tip. Questions about how to do that? All right? You do those real quick. You don't even have to write them down. You already wrote some down. Real quick, figure out what they're in your head. Just make a small note in the margin of what those are. We'll talk about them in about 60 seconds. I'll grab an answer so I can grade something. Stupid meat out of it. All right. What's the first one? What do you think it is? Oh, this place is correct. And the second one? I think it was correct. And the third one? Correct. The fourth one? Combustion. And then the last one? Questions about any of the 5? The third one was decomposition with no plus sign. What? Oh, hang on. Okay. You need me to wait? Okay. You done? Okay. So, we're going to start with predicting for yellow back there who did not like my title. All right. Predicting product. And we're going to start with single displacement. We're going to do single and double displacement today. The nice part about it is the steps are the same. So we're only going to write them one time. All right. Number one. Look up the oxidation number of all elements. Number two, switch, okay, the element with the same sign. Okay, now by saying sign, I mean both positive or negative. You're either going to have two that are positive or two that are negative. You're not going to have both. Now, when we get to double displacement, you'll have two that are positive and two that are negative. That's how it's different. Number three, do not take any subscript across the yield unless part of a polyatomic ion. Number four, put in new oxidation numbers on the product side and crisscross. This is where if you stick at word equations, and you can't write the name of a formula using oxidation numbers, it's going to be difficult for you to do this. If you do well with it, this should not be an issue. And I painted on Friday night, and then Saturday night I unexpectedly had to come apart. Yeah. My son loves slime. He makes slime. I lots of slime. Only it deteriorates over time. One of his containers exploded. And it's foul smelling in the house. And unfortunately, you changed the whole carpet in very large areas. But I have to replace that. So I had to shampoo one area of the carpet so that it doesn't smell like a dog died. And I'm still really angry, but you know, at least I'm not on the channel 2 or 12 news because I couldn't. Because for a while it was touch and go. All right, this is a
standard single displacement reaction. How do you know? There you go. So, according to the steps, the first thing we need to figure out is the oxidation number. Because according to single displacement, two elements are going to switch places. You need to figure out who is going to switch places. So, Al has what oxidation number? All right, is it positive or negative? Okay, here it's important to know who's positive and who's negative because you need to know the signs to know who's going to switch. Are the two positives going to switch or are the two negatives going to switch? All right, sodium has what oxidation number? And chlorine is? All right, so in this particular case, who is switching? The two positives or the two negatives? All right, the positive oxidation numbers are switching. That is all you need to know about the positives and the negatives. It doesn't make any difference about the numbers themselves. You needed to know if the positives or the negatives were switching. Now, we're not putting them together. We're switching them. So, Na is going over here, and Al is going over here. They're switching places, okay? So, who is with the Cl currently? The Na. So, who is going to be with the Cl after it switches? All right, so Al is now the Cl, and Na is going to be by itself. Okay? Question. There are no numbers in this one. I picked a really easy one just to show the switch. I'm going to put numbers in the next. Yes. Yes, you could have written it Na plus AlCl would be the exact same thing. Does not make any difference. All right, now, step 3 says, don't take any subscripts. I gave you one that didn't have any to make this one easy. All right, put in the new oxidation number. All right, so we have a compound. This is a compound, right? What do we always do if we have a compound? Crisscross. So aluminum has a +3, chlorine has a -1. 3 comes down, 1 comes down. And A is by itself and it's an element. Is it one of the 7 diatomics? Do we put anything on it? It stays by itself. If you had written it the way Taichung said, it would have a 3 there, and they would have nothing. So, if I rewrite this, so it is not full of crap, I did not put this in the steps, because what did I tell you we would always do in the equation? Balance it. Is it balanced? How many chlorines are here? What are we doing here? How many NAs do we make? 3 there, 1 Al, 1 Al, it's good to go. It's not difficult. If you can write a word equation and you are proficient at writing formulas, this is not difficult. Okay? Everybody got it? Can I move to another example? All right. There's on some subscript fault. So, Sb2O5 plus F2. 2. Really? I cannot survive a week with that.
It's gonna be a week.
Oh, yeah. All right. So SB has what oxidation number? Really?
Oh, no.
Wait, what?
I know that's okay.
Oh,
All right. So SB has a +5. Here, let me-
that's fine.
All right. Has a 5. Oxygen has what oxidation number? All right. And fluorine has a. All right. Now, this is the part that you're going to have to memorize. Look up on your oxidation sheet. You know your Hector now owns 5 clear brown iguanas. The 5 clear brown iguanas. They all have -1, +1, +3, +5, +7 written on the sheet. Okay? They all have it. When you look them up, they're all going to be -1. Okay? Every single one of them. And every time we use them, most of you are going to raise your hand and go, Ms. Wall, which oxidation number do we use? I'm telling you. It's -1. Okay, you're still going to ask me 500 times while we're practicing. And while we're practicing, I will still tell you it's -1. But on test day, some of you are still going to come up to me and go, Ms. Wall, what oxidation number do you want me to use? And on test day, I'm going to say, remember. Okay, it will come back to me in about an hour and a half, or 45 minutes, or in a little while. It's possible it's Friday, but with a short day tomorrow, will probably be next Monday. Okay, so given that fluorine is -1, so who is switching this time? All right, so the negative oxidation numbers switch. All right, so tell me what I'm getting on the other side this time. SB who? Okay, I'm going to write this for a second. Don't write it down. Those of you writing where they do not write. All right. Now, this happens a lot. People tell me to put things like F and O together. If you put the F and O together, you have a -2 and a -1 oxidation number together. When we write formulas, what 2 oxidation numbers have to go together? A negative and a. So, if you put 2 negatives together, can that work? No. Remember what I said. The oxidation numbers are switching places. You're not putting them together. They're switching. So the F is going here, and the O is going there. So, what are we getting? SB is going to have F, and O is taking its place. They're switching. It happens all the time. People take the 2 that are switching and they stick them together. It's a common mistake. Okay? Now, notice all these subscripts. Do they get to cross the arrow? No, they're not part of a polyatomic ion. They all have to stay on this side. So where do all these subscripts come from? They have to get new oxidation numbers. This is a compound. So we crisscross. This is an element. Just like you did over the weekend. Compound. What's SB's oxidation number? 5. What's fluorine's oxidation number? -1. 5 comes down, 1 comes down. O is an element. We don't put anything on it unless it's one of the 7. Is it one of the 7? Then you put a 2 on. So if I clean this up without all my drawings in it, You have that. Is it balanced?
No.
So you want balance first. Not a good choice. Go with the biggest oxidation or biggest subscript. I would go with O because O is attached to this SB with that 2 on it. Okay? Personally. You can show you something else if you're going to erase. Okay? So how many O's are here? How many O's are here? So, based on that, we're going to need a 2 and a 5. So how many SBs do we make? So 4. How many? Question. All right, let's do one with the polyatomic ion. That'll work. All right. Tell them what actually tell them why you say it exactly wrong. They can happen anywhere in the world, in nature. They can happen in a lab. They'll happen in your body. Like antimony is found in rat poisoning and that. So antimony would be something that would happen inside of a rat's body when you put ant poison out in our people. Rat poison. Ant food. I mean, elements look much different than what certain compounds look like. I mean, sodium metal itself is a silver sort of soft metal, but it doesn't look like that when it becomes table salt. The white granular solid gets all new properties when it becomes a compound. Doesn't look the same as elements of sodium. It changes. Like magnesium we use on Friday. Silver ribbon-like metal that we use and broke up into the stuff. But once it becomes like milk of magnesium, have you ever seen anybody use milk of magnesium? Because they have okay, if you have an upset stomach, you can drink it. It's a white milky liquid. A lot of people use it if they have an upset stomach or they need to throw up or they have really bad diarrhea. Oh, you can use it for those purposes. Can be. Can be. But it gets all new properties in the compound. That is, I can't remember the core of it, but it's just a crystal. Yeah. Yeah. Yeah, I had it colored this weekend. It was quite gray. Gray. I have to get my driver's license renewed. I really don't want to put down that I'm gray. Yeah, it'll lighten up. If I wanted to have it done Friday with be lighter this week after I had it colored, but no, I spent most of Saturday shampooing copper thanks to my son. So didn't get to work out that way. I'm a little bitter about that too, by the way. It's all good. All right, so if we look at aluminum sulfate, aluminum, what's its oxidation number? And sulfate. Okay, and potassium. Okay, so this time when we switch, what is the only number that gets to go across that arrow? Who? All right, let's go back to the step. The only number that gets to go across is part of the. All right, so go back to my equation. Who is part of the polyatomic ion? The 4, the SO4. You have your hand up or you stretch? Okay. So whatever's in these parentheses gets to go across the arrow.
So, who's switching? The K and the who? This is switching with that. The two positives are switching. So K is going over there and AL is going over there. I know that, but Shatoria did not. So we're fixing Shatoria. So K is going to be with SO4 and AL is going to be by itself. Now, just like Tyshun said a minute ago, if you had written it as AL plus K SO4, that would be the same thing. There's nothing different about those two answers. Just because I wrote the KSO4 first, you could have written the AL first. Okay? It doesn't matter the order you write them in. Now, I have never, in all the years I've been teaching, been taught that. So no, they do not. All right, +1 and -2, so a 2 comes down. Aluminum is by itself. Is it one of the 7 diatomic elements? Then you put nothing on it. It gets absolutely nothing. Okay, so we have Al2 SO4 with a 3 plus K, and maybe Jeffrey's chemistry teacher required him to do something weird like that. But I have never heard that in all my years. That is fabulous. I've never. So there's 3 SO4. So 3, 6, 6, and then 2 aluminum. What may we do for you, my dear? I do. Only if she's going to beat the drums to death. I'm aware. Tell her she's only been gone, what, a half hour, and I missed her tonight. Oh. What do you know about? I don't know. They have like a weird little thing. For real? I can't all the way. No, I want him gone. Okay. Not soon enough. All right. Now.
Oh my God.
This is why we're behind fourth period. All right, double displacement works the exact same way, which is why I do them at the same time. They're identical. We're going to do an example or two just so you have the way it works. All right, so. Okay. Now, what's different about this one than the last 3 examples we worked? How can you tell they're different other than I wrote double displacement at the top? Exactly. Okay? You should be able to recognize at this point, after our discussion, that these are 2 compounds, which is how you tell it's double displacement. So, the steps are identical. What did we just do in all 3 last examples? We still do the same thing. We still find the oxidation number. So what's nickel's oxidation number? +3. How'd you know that, Nada? That's right. So if you look up nickel on your oxidation sheet, because some of you are still struggling with that, nickel has multiple oxidation numbers on the sheet. So look at the formula. This 3 came from the nickel. Chlorine's oxidation number is, all right, same thing with iron. Iron has multiple oxidation numbers written on the sheet. Iron is, and bromine is, there you go. All right, so when we look at this, what do we have? So, does it matter this time which one we switch? You pick, okay? If you see it as switching the two positives, switch the two positives. If you see it as switching the two negatives, switch the two negatives. The thing I would say to you is whichever one you see, you do. It be consistent. Okay? I like the positive, so when I do it on my paper, I switch the positive. But if you like switching the negative, you switch the negative. All right? Switch the one you like. I tend to switch the positive. Which one do you want to switch? I heard more positive. So Ethan, you were output. You switch it negatively on your paper. Okay? Switch either positive or the negative. You can do it either way. I tend to do the positive. So in my mind, when I'm switching FE goes over here and nickel goes over there. So FE is now going to be with who? CL. And NI is now going to be with who? All right, so when Ethan was doing it in his head, he's switching. So CL is now going to be with who? And BR is now going to be with who? But it doesn't matter which way you do it. Now, since there are no polyatomic ions, do any of those numbers come across the arrow? No. No. So then, my oxidation numbers, Fe has a +2 because I didn't erase them. They're still right there. Chlorine's a -1, crisscross. Nickel's a +3, bromine's a -1, and bring them down. That's one reason I tend to write my oxidation numbers at the top, because that way when I need them on the other side, where are they at? They're right there. They're easy to find. So Ni, Cl3 plus Fe, Br2 goes to Fe, Cl2 plus Ni, Br3. Who you want to balance first? All right, how many bromines are here? How many are here? So I need a and a 2 to make 6. All right, from there. Okay. I made how many chlorines? So, and we got it. Question. You think you got them? Know how to do them? Can we talk homework? All right. Because, you know, apparently I need to be extra explicit. You guys can keep doing way down what you're supposed to do. I like going to well, I'm glad. I want to talk back. Right. Oh, yeah. Why I said I need to be extra explicit today. No, you're not. Yeah. Hang on 1 second. I need my able-bodied assistant to take it out there. She's not very good at it. For the start, I like to use the last week. Other than that, I don't no. Bro. Well, I'm getting ready to tell you. I'm waiting on my able-bodied assistant back there who's not very good at this job. Alright, is she done? Did you get one? I'm working on it. Alright, so on the piece of paper, it says tell type. Everybody find one that says tell type? Y'all are literally just telling type. Do not balance them. Don't do anything to them. Just very quickly run down it and tell me the types of reaction. All of those. Okay? S, D, 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 S, C. Just put the initials. You don't even have to write out the words all the way. Now, on the other one, for my geniuses who keep doing extra, okay, on the front, okay, the front side only, only. I want you to do 1 through 4, Okay, 1 through 4. I just gotta make sure I pick the right one. And 7 through 11. 1 through 4. And 7 through 11. I just figured if you could do 1 through 4, you could do 5 instead. You can do them all if it makes you happy, John. I was just trying not to get crazy. I figured you had other people's homework to do. You didn't need to do a ton of chemistry.
I was wanted to go more.
I mean, but if you don't and you need to do some extra, knock yourself out. I mean, we're not going to do the other on the front. But if you want to do them all, go for it. I don't have an ADBD class, so I have no clue. There you go.
Oh, we're trying to bring back.